Why is that? One reason, it's really expensive. Despite titanium being the 9th most common element in Earth's crust at a percent weight of 0.6%, there is more titanium in the Earth's crust than carbon, an element no one considers rare. Yet, in its purified form, it currently costs about $4,500 per metric ton. Aluminium, in comparison, costs a third of that at $1,500 per metric ton, which itself is a relatively expensive metal as a result of the high-energy electrolysis refinement process. To boot, that is today's price, which has dropped dramatically since the SR-71 was created. Titanium is expensive because its refinement process is a nightmare. To make titanium, we start with the feedstock in the form of titanium dioxide with this chemical formula. This oxide ore, called rutile, can be found in high concentrations in these dark, sandy soils. To build the SR-71, the US needed to buy vast quantities of the mineral from the Soviets, who had large deposits of rutile. To do this, they purchased the material through ghost organizations to hide the final destination of the material. Had the Soviets known what they were helping to build, they would not have sold that material. However, the US likely could have just purchased the material from mines in Australia. This is a relatively common raw material and is primarily used as a white pigment for paints, and is even found in sunscreen lotion as an ultraviolet radiation blocking pigment. Our trouble begins when we need to separate these two oxygen molecules to get pure titanium. For iron ore refinement, we heat it in the presence of carbon to force the oxygen to separate from the iron and bind to the carbon to form carbon dioxide. With aluminium oxide, its melting point is too high, so we instead dissolve it in a solvent and then use electrolysis to separate the oxygen molecule. Neither of these methods work with titanium. Titanium dioxide is both thermally stable and resistant to chemical attack. In the 1940s, the first reliable process to produce a chemically pure form of titanium was developed, called the Kroll process. This process made the SR-71 possible. It begins by first converting the titanium dioxide to titanium chloride. To do this, titanium dioxide is mixed with chlorine and pure carbon and heated. Any oxygen or nitrogen leaking in will ruin the process, so this has to be done in relatively small batches in a sealed vessel. Once this process is complete, we have titanium chloride. We then need to purify the titanium chloride from any impurities in the titanium ore through distillation, where we heat the product and separate titanium chloride using its lower boiling point. This titanium chloride vapor is fed into a stainless steel vessel containing molten magnesium at 1300 Kelvin. Titanium is highly reactive with oxygen at higher temperatures, so the vessel also needs to be sealed and filled with argon. Here, the titanium chloride reacts with the magnesium, which itself is an expensive metal, to form titanium and magnesium chloride. This reduction reaction is extremely slow, taking between 2 and 4 days. Then, once the reaction is complete, we need to let the product cool before removing the magnesium chloride products through high temperature distillation once again.